So we now invite the audience to ask questions from the panel. I think there are microphones here in the room.
Try to squeeze in two questions if I can, one for Erin, one for Erin. So on the helical anchors, the veins, have we looked at how those work in an environment like Maine where we have frost depth considerations and some of the you can have soil movement away from veins? Will those work in an environment like Maine? Do you think? And for Erin, what are some of the buoyancy considerations with using the foam glass aggregate, and how are they accommodated?
I'll start. We have left the anchors in the ground over the winter in Missouri. They do have a certain amount of frost penetration. We did test them the next year. There was additional strength gain, and that's probably attributed to some freeze and setup that occurs, in a clay profile like that. I think a lot of it's going to depend in Maine, in areas where you get really wet. It's going to entirely depend on the soil conditions. I'd certainly anticipate the soils would be weaker in the spring, or in periods where we certainly have a thawing period occurring and a lot of water getting into the soil. That would be no different than anywhere else. So in any case where you're going to use it, you're going to have to consider the soil conditions that we're using. That's no different than a typical detail that you'd use now. So the answer I think is yes, certainly it'd be applicable to an area where frost action might be anticipated.
I guess to speak to the question about buoyancy, it is buoyant, and most of the embankments, it's up high enough in the embankment that it's not below groundwater levels, so not an issue. In the two areas that we did have it at the culverts, we only had excavated a few feet below ground surface, but groundwater was fairly low there. So the weight of the additional FGA and riprap and roadway section was enough to make that stable, but I think it is a consideration. And interestingly, at one point they had placed a few feet of it, and then it had rained over the weekend and they hadn't dewatered. And there was even paint on the surface with some elevations, just to mark where they were at grade. And the whole area just all floated, and there was several feet of water, and then the FGA floating on top of it. And multiple people did not realize that it happened, and they walked right into it. Like they thought they were walking onto a solid surface, and instead they walked into the water. So yes, it does float, and buoyancy is a factor. Yep.
Yes, please go ahead.
I just had a question about the foam glass fill. EPDs are kind of hot topic today. I was just curious how all that balances out. I mean, it's a green material, you're preventing things from a landfill, but it's also not a local material, so there's a lot of increased trucking. I'm just wondering if that was looked at all and how it balances out.
That's a good question, and some people have raised issues of, it takes energy to produce it also. So that's another, so there's the trucking aspect, and also the kind of the kiln that is used to melt it. So it's something, I guess, on this project, we really kind of needed this product, and I can't say that we looked very closely at the trucking, impacts. I will say I was talking to Aero Aggregates earlier about this question, because like you said, it's a balance. Like, you are doing something beneficial by taking that glass kind of out of the waste stream. It's also avoiding excavating soil or processing rock. That's rock that you're not now crushing and using. So I think that's a benefit. And Aero Aggregates is working on switching over to electric kilns and then they can use other energy sources to try to help balance that kind of footprint. But it's definitely something they're working on and trying to balance.
Thank you. A quick follow-up question to that, Erin. Did you also consider other options as light fill material?
Yeah, so we looked briefly at expanded shale aggregate is another kind of lightweight fill material that's easy to use. It has a unit weight of 65 pounds per cubic foot though, rather than 15. So it just didn't quite work here. We also looked at there's like a lightweight cellular concrete and EPS geofoam are two other lightweight materials that are used in this type of application. All three of those were similar order of magnitude for costs. But from a constructability standpoint, and we had monthly constructability meetings with the DOT, their designers and their construction staff. And so we kind of worked together to look at what the solutions were. And the foam glass aggregate can be handled by normal earth moving equipment. And it's sort of like easy for the contractor to place and compact with their usual equipment. And it also doesn't have any special details, like geofoam has to have a membrane on the top and leveling sand. And, that's all doable, but this was just kind of nice because it didn't have those detailing requirements, and it didn't require a specialty contractor. So that kind of pushed us towards that direction.
Thank you. No, okay.
It's just about like the cost. Can you give us a little bit of a sense of how much more per cubic yard are we talking about?
Yeah, so I guess I don't have exact numbers with me.
A ballpark.
It was on the order of $100 to $150 per cubic yard. So definitely much more than like a standard
Like
aggregate.
10,
Yeah,
at least 10.
but it was better than like using piles to support the embankment or something
Right.
like that. So, but it's definitely, yeah, it's not cheap. And it's, I think now that Sargent has used the material, hopefully they are more comfortable with it. Because a part of that is the material cost and a part of it is obviously placement cost. So, yeah, that was an in-place cost.
Yeah, so not the 10 times that you're saying. That's not just the pure aggregate
Oh,
cost.
okay.
That's
So what is it? What's
placement.
right,
yeah.
right. But
And
what's
I don't know,
what's a
like,
typical?
yeah, I guess I
placement.
don't know because
Something you might see today, I mean, it can range, but you can see it anywhere $50 to $80 sometimes a yard, depending
Oh.
on where you're working.
All right.
So
So two.
maybe
times.
something like two,
Two. Okay.
I think is.
Sounds good. Thank you.
Question I had, Ramesh, was related to the construction on the moon. So there are, like you mentioned, the in-situ resource utilization program, and then the regoliths. There have been discussions on how to use the regolith on the moon as a potential material. Can you please talk a little bit about the effect of the temperature fluctuations that you mentioned is huge on the moon on this type of potential material, construction material?
Yeah, the temperature fluctuation or the high heat could be taken as positive day. The one thing they are thinking now is sinter regolith. You can sinter the regolith the high temperature, make it harder, more rigid maybe. The key thing there on the moon is that after maybe couple of centimeter it's couple of inches below, it's very hard solid soil, which regolith they call it. That happened because as the moon is dry, right, and it's shaken continuously, millions of years shaken, and then it's compacted very, very well. So they are also thinking maybe to build a road, right? They can process at the surface of the surface of the moon after getting rid of the dust, the fluff from outside. So that's a benefit in a sense. Now the temperature is interesting. The temperature rising and cooling creates moonquakes. You know, one of the cause for moonquake, there's no platonic movement like here, right? But there, temperature fluctuation is giving the moonquakes, and moonquakes, Richter scale, they are estimated around 5. It's not very strong moonquake, but it goes long, by the way. It goes half an hour continuously shaking. So now if you want to build infrastructure structures, you know, on that kind of environment, it's going to be challenging. And NASA's plan, NASA's requirement going to be after in a long term. Okay, they're trying to think 80% of whatever you do there should be from the material process over there, because taking from here is very expensive, right? So they want to really process this in situ materials and mine, manufacture, you know, a lot of drilling technologies built. So they want to mine and process material, and 80% it should be used to build anything on the moon. That's for long term. So that's the thing I would say, because it's very quite a bit of research is going on regolith processing also. 3D printing is another one. They really want to use the lunar regolith, lunar soil for 3D printing purpose. NASA has funded, there's a company called ICON, ICON, and that company does a lot of 3D printing of civil engineering structure here too. So they got a big contract with NASA to work, to look into the 3D printing of lunar regolith to build habitat, to build other facilities in the moon. So that's kind of a big thing. Thank you.
Thank you. Yes, please.
Erin, this is a question for you. I noticed that you did lateral testing and torsional testing, but didn't do the pull-out. So I presume that's not a big concern. But if you were to, for some reason, if a sign has to be removed, is the plan to leave the foundation element in ground, or is it easy to move out? Take it out.
Thanks, Mandar. No, that's a good question. We didn't do pull out. When you say pull out testing, are you thinking to actually test the axial capacity of the anchor?
Yes.
We're effectively doing that now because we're trying to come up with another installation technique where we're going to rely on the tensile capacity and effectively just use a hydraulic cylinder to push it in and basically use the pile itself as a reaction frame. So that would add two ways to install the element. So in that way, we've done it. Now, what we do is basically, if we want to take it out of the ground, yes, we basically have pulled it, we've spun it out. What you have to do is basically spin it, basically create the cylindrical shear surface, you get that residual strength, and then you can rotate the pile out of the ground. So the idea is, and one of the selling points is foundation reuse, which you were alluding to. So that's one of the nice benefits there. Yeah. But every single one that we tested was taken out of the ground. And we would actually reuse the same pile for every vein that we tested. So it's that way we weren't instrumenting a new pile every single time. So it's just by the means of us testing it, we did that, reuse the foundation.
A follow-up question, Erin. I'm assuming you also have considered other applications, transportation related. Can you please talk a little bit about that?
Yeah. So we've kind of have our idea of where they'd be useful in applications. We also we actually have a partner. It's called Helix Mooring. So obviously those are marine applications in that respect. And so they've actually contributed to this project a lot. The testing that we did early on where we're doing pure lateral, but basically pulling right at the base, that's applicable to more marine applications, whether it's vessels, aquaculture cages, scaled up wind turbines, things like that are going on elsewhere. So that's where this could potentially be advantageous. So we do see definitely outside of transportation, this being used in marine applications. Hubble's plan, and the composites folks in the room would be excited about this, is they really want to develop a composite anchor, particularly for marine applications for obvious reasons, with the saltwater corrosion and everything else. So I think that's kind of that's one of the directions they're also heading. Yeah.
Great, thank you. Is that the question? Okay. So going back, Ramesh, like the theme of the conference is driving research into practice. So what are your thoughts on basically what you presented, the Moonshot, and how the lessons that we can learn and then make those ideas more applicable in transportation?
You mean transporting from moon to here, or are you talking about?
Yes, yes, the knowledge and the technologies that have been developed and how we can.
Yeah, I was actually talking with some of you earlier. Our climate sensing, right, is becoming so extreme. You want to do a lot of the business should be done in different way for all these extreme climate. So now that won't be better platform than working on the moon and getting the knowledge earned there to bring down here. So you don't find extreme heat and cold like in moon, right? And also surviving in this lunar night kind of situation, surviving like in this radiation kind of environment. I mean, this is gonna really generate, I believe, in future technology, which will be, I think, directly helpful to us here on Earth, So it's challenging. I mean, we learn to work on this challenging environment. I mean, we take a lot of things here as granted, right? Everything, water and roads and build a house, live, everything as granted. But there, when you go first time, what are you gonna do? How are you going to survive those kind of harsh environment? But still working in a harsh environment, I think a lot of innovation should come out of that, So temperature, I mean, temperature rising here too. So we have to really worry about if we build structures, bridges or buildings, thermal stress. Here we don't give much consideration to thermal stress right now, but at moon, thermal stress is going to be I think, the first consideration for loading. Depending on the support, if you make a very rigid support at the base, you're going to have a high thermal stress, right? So you have to design the base, a foundation, a very different ways. And so there's a lot of lesson to be learned there first, and then maybe transfer down here. So that's what I would say. Thank you, Ehsan.
Thank you. Any other question from the audience? Okay, so I would like to thank you, the panelists, for the great conversation.